Welcome back. We are about to discuss the legacy project. So legacy project is an existing software project that becomes difficult to maintain and understand or extend over the time. A project is not just a source code, it includes the build tools, the deployment scripts, the dependencies on external systems, the infrastructure, the project documentation, and even communication methods between the developers and stakeholders. As these elements evolve over many years, the project gradually becomes more complex and harder to manage. For example, an enterprise application may depend on outdated libraries, undocumented deployment scripts, and old server environments, and making even small updates becomes difficult and risky. One major characteristics of legacy project is age. These systems often pass through multiple generations of developers and maintainers. As team changes over time, important knowledge about the system's original design, architecture, and implementation decision is gradually lost. For example, developers maintaining a 20-year-old banking system may not fully understand why certain modules were designed in a specific way because the original developers are no longer available. So this loss of knowledge makes maintenance and modifications increasingly difficult. Second characteristic is large, that is legacy systems are also usually very large and complex. Because these systems support critical business operations, replacing them entirely can be extremely costly and risky. As a result, organizations continue maintaining and extending them for many years. For example, government databases, airline reservation systems, and telecom billing platforms often contain millions of lines of code and support thousands of users daily. Their size and importance make them difficult to replace, which is why they continue evolving into legacy systems. Another common characteristic is that legacy projects are inherited. The people currently maintaining the system are usually not the same individuals who originally developed it. New developers must work with unfamiliar code, the technologies, and the design decisions without having complete historical context. For example, a software team may inherit an old healthcare management system written decades earlier using the technologies they have never worked with before. So this makes the understanding and modifying the system much more difficult. Legacy projects are often poorly documented. Over the time, documentation may become outdated, incomplete, or entirely missing because changes were made directly into the code without updating the design documents. As a result, developers spend large amount of time trying to understand how the system works before making even small modification. For example, if a deployment instruction or module relationships are undocumented, maintaining the system becomes slow, risky, and error prone. However, it is important to understand that not every old project should automatically be considered a problematic legacy system. A great example is a Linux kernel. Although it has been under development since 1991 and is extremely large, it has maintained a very high level of quality through strong engineering practices and continuous maintenance and active community involvement. In fact, a static analysis study conducted in 2012 reported a defect density of only 0.66 defects per 1,000 lines of code, which is better than many commercial systems of comparable size. So this shows that age alone doesn't make a project legacy. The real issue is the maintainability, the quality, and how well the system evolves over the time. One major characteristic of legacy project is untested and untestable code. In many older systems, proper automated tests either doesn't exist or are unreliable. Since technical documentation is often outdated or missing, developers frequently depend on test cases to understand how the system is supposed to behave. A good test suite can act as a practical documentation by showing the expected inputs, outputs, and design assumptions. However, when testing is weak or absent, developers become afraid to modify the code because even small changes may unintentionally break the existing functionality. For example, imagine modifying a payroll calculation module without test. A small update could accidentally affect the salary processing for thousands of employees without being detected early. Another common issue in legacy system is inflexible code. In such systems, even small feature request or behavior change may require modifications across many different files and modules. This usually happens because components are tightly coupled and poorly structured. As a result, a small change can trigger unexpected side effects throughout the system. For example, adding a new customer type in an old banking application may require updates in account management, billing, reporting, and authentication modules separately. To make matters worse, every change must often be manually tested, making the development very slow, expensive, and risky. Legacy systems are often heavily burdened with the technical debt. Technical debt occurs when the developers implement temporary or quick, or you can say hacky solution to save the time in the short term instead of designing proper long-term solution. While these shortcuts may solve immediate problems, they gradually reduce the overall quality of the system and make the future development more difficult. This is similar to taking a loan. A quick solution provides immediate benefit, but over the time, interest accumulates in the form of increased complexity, maybe harder maintenance and slower development. Until the system is cleaned up through refactoring and restructuring, developers continue paying the interest of this technical debt through increased effort and reduced productivity. Now let's have a quick quiz. For each scenario, decide whether the software system should be considered a legacy project or not, and think carefully about the maintainability, the documentation, testing, flexibility, and technical debt, not just the age of the system. The scenario says that a banking application has been running for 25 years. The original developers left long ago, documentation is outdated, and even small updates require weeks of testing because no automated test exists. So, is this a legacy project or not? This is clearly a legacy project. Although the system is old, age alone is not the only issue. The real problems are missing documentation, loss of original developer knowledge, and lack of automated testing. So these factors make maintenance risky and difficult, which are key characteristics of a legacy system. Next, an e-commerce platform has been running for 15 years, but it's continuously updated with automated tests, active documentation, and modern deployment tools. Developers can safely add features without any major risk. So is this a legacy or not? So even though this system is old, it should not automatically be considered a problematic legacy project. The system is still maintainable because it has strong testing practices, updated documentation, and modern engineering support. And this is similar to the examples like we considered and discussed about Linux kernel, where age doesn't reduce the quality or maintainability. A hospital inherits a patient management system written in outdated technologies. Current developers didn't build the system and struggle to understand how modules communicate with each other. So is this a legacy? This system demonstrates that inherited nature of legacy projects. So this is a legacy project. The current maintainers lack the historical knowledge and must work with unfamiliar technologies and undocumented design decisions. As a result, understanding and modifying the system becomes difficult and risky. An airline reservation platform contains millions of lines of code and supports thousands of users daily. Replacing it completely would be extremely expensive and risky, so the company continues maintaining it carefully. So this is a legacy project because it is very large, business critical, and difficult to replace. Large enterprise systems often survive for decades because rebuilding them from the scratch would involve huge, you can say, operational risk and financial risk. So their size and complexity makes maintenance increasingly challenging over the time. Developers repeatedly added quick fixes and copied similar code into multiple modules instead of redesigning the payroll system properly. Now, even small updates can cause unexpected issues. So, is this a legacy project or not? So, the system is a legacy project because it heavily affected by technical debt, which is a major characteristics of a legacy project that we just studied. Short-term quick fixes may solve immediate problems, but over the time they reduce the code quality and increase the complexity, and eventually the system becomes very difficult to maintain, extend, or modify safely.